session of solutions, as I had said. Now I want us to consider a past exam on probability and statistics, and straight away the exam is this. So this is Cambridge International Examinations, and it is Mathematics Paper 6, Probability and Statistics 1. The code is 9709/62. And our question of interest that we want to look at is this particular question. Now, this is a probability question that involves particular defined events, that is event R and event S. And these events are defined within the domain of a fair eight-sided die, which is thrown twice. So the question reads, a fair eight-sided die has faces marked 1 to 8. The score when the die is thrown is the number on the face the die lands on. Now the die is thrown twice. Event R is one of the scores is exactly 3 greater than the other score. Then event S is the product of the scores is more than 19. So here are two events defined. One of the events is that of one of the scores is exactly 3 greater than the other score. And then the other event is the product of the scores is more than 19. So the Roman 1, we are asked to find the probability of R. Then Roman 2, we are asked to find the probability of S. Roman 3, determine whether events R and S are independent, and then justify your answer. So I'll be giving it a different approach. So basically, I know the language that most learners who are in high school are craving to know is that of Python. So I'll use Python to demonstrate this particular solution. But it should be noted that in the Python environment, you still need to give it arguments in terms of formulae so that it gives you out the answers. So for one who would want to do it manually for the purposes of getting marks, you can follow the rationale. You can follow the method or the steps as they are spelled out in Python environment. Remember that Python environment also takes up commands. So if we want to solve this particular problem, we'll actually be giving it arguments. Now those arguments are the ones you needed to make on paper to arrive at the right answer. So I hope this will not only help you know how to answer this question, but it will also demonstrate to you how to use Python to solve such kind of questions, and possibly I'll extend to show you how you can use the same to for visualization. Okay, so straight away I move to that. So I launch Jupyter Lab. So we'll wait for it to launch. Once it does, then we'll be able to, yes, like it's almost. Once it does, then we'll be able to input our arguments and have an opportunity to see our solutions in terms of a printout. So let's see. Okay, let me close those windows. I want to open a new one, right? That's where we are. So I should rename it as, let me see, looks like I also have, oh, it opened in a different window. That's still okay. So I'll I'll rename it as probability. I'll rename our notebook as, let me just name it as 9709. Yes, probably 9709 stroke 62. Yes, so I'll rename it as such. Oh, it can't take stroke, so I'll just rename it probability and statistics. Yes, as such. You take that. Yes, so we've renamed it. Now we want to set out to solve that particular problem that we have seen. That is this problem here. I want to find a solution to this using Python, just as I've indicated. So first thing, I come here, the first cell, and I will first do this to import the right tools that I need. So I say from ITER tools, from ITER tools, import product, import product. Then having done that, then I need to define the outcomes. So outcomes that we are dealing with there, it must be the right spelling. Outcomes, I'll define outcomes to be a list, and in this list, it's a list, and I call it product, and the range, it's product. Then I need it within the range 1 to 9, within the range 1 to 9, within the range of 1 to 9, within the range of 1 to 9. And we are saying, as that is happening, because we are doing the pickings twice, the throw is done twice. So we say repeat. How many times? 2 times. Repeat 2 times. Sorry. Repeat 2 times. So we have that. And so that is of the outcomes. We have, you see, we have defined the range 1 to 9. It should be noted that if you define the range 1 to 9, then it means 9 is not included. So it's just between. So the values, the actual values are 1 to 8. Well, so I say total outcomes, total outcomes. So I want to define total outcomes as length. So len will give me the length of outcomes, because it's in the length that we'll be able to know the number of possible outcomes when we throw this die twice, because it has 8 equally likely faces. And if we throw it twice, then we are interested in particular events, those of products in the first throw and the second throw give you greater than 19. Another one is that the difference between the first and the second throw is exactly 3. So those are conditions. So for us to get such probabilities, then we need to know the length of the outcomes. So I'll be saying outcomes, and realize that outcomes, we have defined outcomes to be here. So outcomes, so that's what we have. Well, now next thing that we do is now we say because we'll be expecting outputs that we are able to read. We are also expecting outputs that we are able to visualize. But for this purpose itself, I'll just be expecting a printout of the output. So every time that I make an argument, I would want to see what, if I run it, comes out. So I will say print. I will ask it to print what? So it's print that. So that's a way of telling it that now I want a string. So total outcomes, total outcomes, total outcomes. It should print total outcomes. And where should it get the total outcomes from? So I'll use the curly braces. I will use the curly braces to pick this, because definitely that's what we are referring to. So I pick that, and that's what I bring inside here as such. So it's total outcomes as such. So what then I need to do is I opened it, I need to close it. Yes, as such. So let me see if I'm right up to there. Yes. So already I'm right, because I see that should I carry out this experiment, a fair 8-sided die has faces marked 1, 2, 3 up to 8. Now, should I throw it twice, then I'm expecting a total of 64 outcomes. I'm expecting a total of 64 outcomes. Very well. So let's proceed and see what else we can do, because we are not just meant to stop at that. Next thing is, now we want to define the event R. Realize that there was an event defined. Event R was defined, and it was defined as one of the scores is exactly 3 greater than the other score. Exactly 3 greater than the other score. So in this case, we are defining in R, we are defining, let me say in R, we are defining AB. We are defining AB such that so these are the intervals. That is, AB should mean, now we are like saying A is outcome in the first row, B is outcome in the second row. So that's what we may we take it to mean. So you return once, okay, we are defining R where R is outcomes where the difference between the first and the second outcomes is exactly greater than 3. So I will ask it to return. So this is absolute of A minus B, of A minus B in situations where the difference is 3. In situations where the difference is 3. Very well. Let's see if that worked out well. Looks like it did without a problem. And so that defines R. I then need to define event S. So I'll define event S. So event S is basically the product of the scores is more than 19. So I'll be saying define in S, define in S, A, B, A, B, A, B as such. So we say A, B, define in S, define A, B, and return A times B is greater than 19. Is greater than 19. That's the second definition. That's the second definition that we have. Then the next thing that we do, we now want to build sets. We now want to build sets for R, S, and R intersection S. So first what we do is say R is equal to R is equal to so we are defining the intervals A, AB, AB for AB in outcomes, for AB in outcomes, for AB in outcomes, if for AB in outcomes, if in R, as we are defined, contains the in R, and we are referring to the same interval. So what we are simply saying here is we are defining the set R, and the set R is made up of the combination of outcomes, which is in the first row, the outcome in the first row represented by A, and outcome in the second row represented by B. So we are saying for such options in outcomes, because outcomes we are defined to be this list here. If in R this we are defined. So somewhere we said define in R as such, and we said it is made up of the event that the difference between these outcomes is exactly 3. So that's what we have here. So if in that. So next, we are defining the event S. The event S, the event S again will now be, so we have A, B, and we say I would have just done this very fast so that we don't waste time. Just like this. Then I bring that here. And this I change to S. This also to S. Then the event intersection of R and S. The event now intersection of R and S. So we have R. And R and S. Probably refer to it as such. So we have we have AB for B in outcomes, if in R We know what in R represented. And in S. Intersection should simply mean the events that are found both in R and in S as we are defined. So they form an intersection, and that's what I'm describing. I'm using this to describe. So this describes the intersection, which then we get as such. So that's what we have. So up to there, we've defined the matched and matched and matched. There is something here that is unmatched. Where is it in particular? R and S here. There is something that is unmatched. Yes, this. It must be this. Must it must be that. Let's see. Right, it was that. So that's okay now. So I proceed. So I want to get the lengths by counting. I want to count the number of events, in number of occurrences in each event. For instance, I want to say count R, count R, that is given by the len. If I write this, that means length. I need the length as in their sum. So that should give me that. Second is I need this. I need to count, sorry. Yes. So I count S. I count S. Count S. Such. And then I count R and S. I define it to be the length. Now it's the length. No, not the length as such. The len is just len as such. And now it's the length of R and S. Now, where did this come from? Just count. Let's count R and S. Count R and S like that. So I want length of R and S like that. Good. I move on. So I need probabilities. Now I want to work out probabilities. I want to give the probabilities, and so first I'll want to give the probability of R. So I'll call it just say prob, then probability of R. Let me call it R is equal to this over total outcomes over total outcomes like that. problem. Mm. Well, it takes that. Then again, the same way I'm going to represent the probability of S. Probability of S. So here I have S. Here I have S. And here I also have S. Then the third aspect that I need is now where probability of R and S. Probability of R and S. So that is okay, probability of R and S. So I'll call that, I'll give it R. Just want convenient names so that they don't bring errors. So probability of R and S. R and S. Probability of R and S. This I will define as probability of R times probability of S. I'll define it as probability of R times probability of S. So it will be this, will be this, will be this. So you see the arguments are just the same as you would have had them on the paper, because what I'm doing is simply giving instructions in terms of the method, the steps that should give me the results. So if you are doing this for the purposes of answering your exams, then this is where you get the flesh to put into your argument. So I have that, divide by this, divide by that. So it will give me here, what does it give me? So that gives me, it's actually, this should be not really, that is misleading. That should be count of R and S, which is this, which is that, divide by total outcomes, which is this, total outcomes that we have defined, total outcomes, divide by total outcomes as such. Then we may also be interested in what PR times PS is, probability of R and probability of S. So probably down here, we may need to bring this times probability of S times probability of S times probability of S as such. So I have all that, and I think up to here I've so this is what gives me the probability of of getting the intersection between events R and P and S. That is the chance of intersection of those events. So that's that. I think I'm done with my arguments. And the next thing that I need to do is to see what my outcomes look like, because now I need to print them so that they are visible. So my next assignment is on having to print the outcomes. And first, what I'll do is say, print, 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 print. So we have this, and so I have this slash, that's the slash that I want, n event is r, and event is r, and we enclose that r. We are interested in it being home. Just a moment. That is what I want. I want a bar. Okay, let me get on screen keyboard so that I get very fast what I want on screen keyboard. Yeah. So having on screen keyboard, what I wanted is inside here. I need this. Yes. I also need another one. So that I make my argument. I make my argument in between that of a minus b. A minus b is equal to 3. Is equal to 3. Then another thing that I do, I put that and then close it because I'd opened it. So if that is done, let's see what we get. Why is it? It's not closed. Good. What's that? So that's what it has printed. Event R. That gives us the event R is defined by the absolute between A and B being 3. Then next thing that I want to print is this. I say print, again print. Now we have like that, and we say some outcomes in S, and this is what we say, first 15, like that. Just a moment before I get there. Though that is also okay. First 15, and what I'm defining is S, and first 15 is given by this command. So this will give us from the first, this basically gives us in the event S, it counts from the first to the 15th. Basically, by counting from 0 to 15, by counting from 0 to 15, that ensures that the 15th object is not included, but there are 15 anyway. So by printing that, though that's not what I needed to do now, let me just do something before I get there. I just wanted to print outcomes in R first. So let's print. Sorry. Should we print? should be print. So we say then outcomes in R, outcomes in R, outcomes in R, and this is what they are, outcomes in R as such, R, outcomes in R as such. Let's see what that would give us. So outcomes in R are this. So these are the events that are possible in R. We see that the combination 1, 4, the difference 1 minus 4 is definitely minus 3, but realize that we were taking the absolute. The other combination is that of 2 and 5. The other combination was 3 and 6. The other combination is 4, 1. So 4, 1, look at the ordered pair. Be keen on the ordered pair. 1, 4 and 4, 1 is an ordered pair. 2, 5 and 5, 2 are ordered pairs, of which both give us a difference of 3. 3, 6 and 6, 3 is an ordered pair. 4, 7 and 7, 4 is another ordered pair. Then 5, 8 and 8, 5 is another ordered pair. All of which give us an outcome of 3. So those are the possible outcomes that we were expected to identify or list. Again, let me see what else we can do. Let's make it look a little nicer by saying print, by saying print. So because I'm calling a string, I'll do that. Then I say number, print number of outcomes, in R, number of outcomes in R. So I should print number of outcomes in R. And how do I get that? How do I get number of outcomes in R? I will use this curly braces. Then I bring in count of R. This one here. Count of R. Like that. Then I run. So I see number of outcomes in R are 10. So R represented, what the event R represented gives us 10 outcomes. Then I would duplicate this so that I get for S, I get for, what did I do? Let me just remove it, delete that, then duplicate it. After I do, then here I have S, and here also S. Now when I print, I get the number of outcomes is 28. And I would also want now to print the probability of R. So to print the probability of R, probably let me also just do it up here. So probability of R, I would say print, print, so I call a string, okay, I want to identify with a string first, like that. And I'm saying you print probability of R as such, probability of R is equal to I bring the curly braces, is equal to count of R, count of R, count of R, which is this, count of R, divide by, divide by divide by total outcomes, divide by total outcomes. Sorry. Where is total outcomes? We have it here. I'll pick that. Total outcomes, I'll pick that. Then I bring it here, of course, in curly braces. So I do that here. Total outcomes as such. And I'm saying all that being equal to, all that should be equal to, again in curly braces, I define, because this is what I defined probability of R to be this, represented as such. So I'll be doing this like that. Because I want the results, I want the resulting probabilities to be in 5 significant figures. So I would say 5F, such 5F, let's see. Good, just brings it as such. Yes, so these are 5 significant figures. 1, 2, 3, 1, 2, 3, 4, 5. So this part here ensures that we get it into 5 significant figures. So this is the probability of R, where we add 10 events out of 64. And that gives us this. That's the probability, 10 out of 64. Probably another thing that we may need to print is let me, for the purposes of not having a very long video, let me access the preparation bit so that I'm able to get them directly without having to take so much time waiting. So I will be collecting. I just want to, I want to do it as a block. Just want to do it as a block. I want to do it as a block. So I take that as a block. Take that as a block and bring it here so that it will iterate some of the things I've done up there. But that's perfect because I'll be having everything in one window like I have here now. But then there's something to fix. There is something to fix. Trace most recent call last. There is something to fix here, and it's in this line. It's in this line. So I'm wondering what it could be. Because it's print or PR and S. Into this here. It's this line here. Count. So this is into this. Count R and S divided by total outcomes is equals to probability of R and S, and put it in 5 significant figures. Now, where's the problem there? Problem is here. Problem could be here. print here, this is equal to times no could be here is not defined, er is not defined. Didn't I define PR somewhere? Should have. PR is defined. PR is defined there. Okay, I see it. Yes. R is not. So which line is this? So which line is this? It's the line of PR times PS. Print PR times PS. I'm just trying to debug so that we move. So this line here. And what we are saying is that we don't have that. Neither do we have that. So it's just that. Good. Corrected. So this is basically what we have. So event R is defined by the absolute difference between the outcomes in the first throw and those